Hello students, in this video we shall discuss few problems on evaluating the double integrals. So the question is, evaluate double integral x square plus y square dx dy over the region R, where R is a triangle bounded by the lines y equal to 0, y equal to x and x equal to 1. Now let us see the region of integration. The region of integration is bounded by the line y equal to x equal to 1, y equal to 0 is the x-axis, and the coordinates or the vertices of this triangle are 0, 0, 1, 0 and 1, 1. You can see the lines inside the triangle. So this is the region R, over which we are integrating the function x square plus y square. Now, in order to integrate, we will have to find the limits for the variables x and y. So since you can see a horizontal red strip in this region R, which means that I am going to first see how x is varying in this region R, and then how y varies. So which means that x takes the variable limits and y takes the constant limits, which can be, so as I said, in the region R, x varies from the line joining the points 0, 0 and 1, 1, which is the line y equal to x or x equal to y, and it varies from x equal to y to the line x equal to 1, and y varies from the least value of y, which is equal to 0, to the maximum value of y, which is equal to 1. So thus double integral x square plus y square dx dy is equal to integral y varying from 0 to 1, integral x varying from y to 1 of x square plus y square dx dy. So since the order of integration is first with respect to x and then with respect to y, first let us integrate x square plus y square with respect to x. Integral of x square is x cube by 3. Integral of y square is x into y square. This is evaluated between x equal to y and 1. So now we get, when we substitute the limits, we get 1 by 3 minus y square minus, when I substitute the lower limit, I'll get y cube by 3 minus y into y square is y cube, and this is a function of y only, which is to be integrated with respect to y between the limits y equal to 0 and 1, which is equal to integral y equal to 0 to 1 of 1 by 3 plus y square minus 4y cube by 3 dy, which when integrated you will get y by 3 plus y cube by 3 minus 4y cube by 3 into 4. 4 gets cancelled, so you'll get y power 4 by 3, which is to be evaluated between the limits 0 and 1. When you substitute the upper limit 1, you will get 1 by 3 plus 1 by 3 minus 1 by 3, and for the lower limit you will get 0, and hence the answer or the value of the integral is 1 by 3. Let us move on to the next problem. Evaluate double integral xy dx dy over the area A, where A is the area bounded by the circle x square plus y square equal to a square. In the first quadrant, now let us see the solution. First, let us try to analyze the region of integration. So it is the circle in the first quadrant, which is, let us consider the y-axis, x-axis, and the circle with center at origin and radius a square, whose equation is x square plus y square equal to a square. And the shaded region is the region of integration. So in order to integrate, we will consider the vertical strip. Either you can consider horizontal strip or vertical strip. Since I have considered vertical strip here, I'll first study how y is varying in this region of integration, and then how x varies. So which implies that y takes the variable limits and x takes the constant limits. So in the shaded region, as I told, y varies from 0 to root of a square minus x square, and x varies from 0 to a. So thus double integral xy dx dy over the area A is integral x equal to 0 to a integral y equal to 0 to root of a square minus x square xy dx dy. So now let us integrate first with respect to y. Since the inner limit is for y, we shall integrate first with respect to y. So that gives x into y square by 2 evaluated between the limits 0 and square root of a square minus x square. So half is taken out. Then you will get x into a square minus x square under root whole square, which is x into a square minus x square. And when you multiply x, so you will get a square x minus x cube into dy. Now it's a very simple function to integrate. So on integration we get a square x square by 2 minus x power 4 by 4 evaluated between x equal to 0 and x equal to a. When you apply the limits, for the upper limit you will get a non-zero value, for the lower limit you will get 0, and hence the value of the integral is a power 4 by 8. Thank you.